Hi, it's Gadget UK here again. This time an Amitech. It's a third-party Amiga Power Supply. So this seems to replicate the current provided by the lightweight one, and it feels lightweight. It's probably going to be almost a clone. Yeah, 5 volts, 4.5 amp, 12 volts, 1 amp, minus 12.1 amp. You got the pin out there, actually. I'm not sure if the original Commodore ones had that on. Yeah, often I can never remember that, but the fact that's on there makes it a bit easier to measure. So this one, again, is faulty. There was a sticker on this that said it makes a ticking noise. I don't know where it's gone. So I think before we plug it in, let's, we'll check the fuse here. I want to check the size of it more than anything. But then take it apart, let's just get the board out, have an inspect of it, measure around, see if we find any shorts or stuff. I don't want to power it on at this stage. So if you saw the previous video, we fixed 3 different power supplies. Well, there wasn't very much wrong with a couple of them in a previous video. So that's a 3 amp fuse there, the red. I can't quite see the 3 amp on it, but that is 3 amp. Let's just tighten these up, make sure they're not loose. Yeah, that's nice and tight. That's nice and tight. And that's nice and tight. And it's a moulded fit in here, so this is you know, no problem with the grip there. You know, you don't even need to worry about tightening that because, well, you can tighten it there. Look, let's just tighten that just for good measure. Anyway, the fuse is okay, and the plug is safe. I'll tell you what, let's just plug it in anyway, see if we can hear any noise. Because I think this is the one that's supposed to make some sort of ticking or high frequency noise. Maybe similar to the one I fixed before. That was a Zydeck one. Is this Zydeck? I can't remember now. Switch it on. Switch it off. No, that ain't making any noise that I can hear. I hope it's not one of these that's got nothing wrong with it. I'm going to measure the voltages actually. Let me get that junk board. It's just got a couple of 7/4 series that I don't care about on it. I hope I'm not confusing myself here and this is a power supply I've fixed before, because I don't know, I've just got this feeling it's not the Zydeck one, is it? Let's have a look on the inside. Yeah, it doesn't say Zydeck, so I think this is another one where it's on now. Let's just measure between ground and 5 volts. Yeah, so there's no voltage, is there? 0 volts. So it is actually dead. So let's get the lid off and have a look inside it. So the same disclaimer I mentioned when working on power supplies before. If you don't know what you're doing, don't go inside a power supply. You could electrocute yourself and maybe either injure or kill yourself. 240 volts in the UK here. Switch it off and on, by the way, like that. May help drain the capacitor inside it. Yeah, but the capacitor, the ballast cap, the main smoothing cap will hold 337-ish volts, or 38 volts I forget. So 240 times 1.414 recurring in DC, so you could get a nasty belt off the capacitor. And obviously if it was switched on, plugged in, and you got an electric shock from the DC side, you could, it could be fatal. So don't work on power supplies if you don't know what you're doing, just the same as monitors and things like that. CRTs, that is. You know, working on a motherboard, you're never going to have a problem generally, because the voltages are so low. But power supplies, yeah, it's just a slightly different beast. Then, you know, if you know what you're doing and you take precautions and things, they are safe to work on, but it's like you've got to be careful. Right, so first thoughts there, it looks pretty cheap and junky compared to the Commodore ones, but I don't know, it looks on everything because you can see lots of flux around here. Obviously it's not plugged in at the moment, so I've got a mains fuse down here. Let's just test that. So, meter on continuity test. Let's just test the fuse. Really? Is it just a fuse thing? It could be one of these where the fuse is blown and there isn't actually a fault. It wouldn't surprise me. Back in the day we used to get, occasionally, a power supply would come in for repair and it would literally just be the fuse. I think before I just swap that out, let's remove the screws that hold the board in, get the board out and just measure around the bridge rectifier and the switching transistor here. Being careful not to electrocute ourselves on any charge that's still in that capacitor there. So yeah, there's going to be probably 4 screws by the looks of things around the perimeter of this. 1, I think this is going to be an easy one, this, you know. I'm not even going to recap this one. I don't think. I will check the caps, but as I mentioned in the previous one, we looked at 3 different power supplies there. Something like this, it looks like it's hardly had any use. The caps haven't leaked. These weren't of the era where they would leak for fun. The brands, well, I'll inspect. Where's the 4th screw? Oh, it's right under there, look. Covert one. Yeah, brand is a part of the thing with things from this era. Right, that's all the screws out. Oh, hang on a minute, it's one of these, isn't it? So unlike the Commodore ones where the power switch slides up, this one's wedged in here, look, and it's soldered on. So that is a pain, isn't it? What I might have to do is sort of lift it and pull it. Yeah, pull it like that, and then leave that connected there. Being careful not to electrocute myself on that capacitor down there. We'll measure that. Something just fell out there. I'm not sure what that was. I will have a look in a minute. It could have been a screw, but it looked like a bit of plastic or something. Let's just measure on volts DC. Just got to try and find that cap now. Oh, it's right down here. So, yeah, so the cap is down here. Let's just measure that. 0 volts. Yeah, so that has drained itself. Just to be double sure, I can use my pliers here, a plastic handle, and just short the contacts. Like that. That'll do. Right, so a multimeter back on continuity test. I just want to check the switching transistor, wherever that is, that's here. So it's going to be these 3 pins here. Yeah, we've got no shorts there. Obviously, do make sure you're making a connection because you've got flux and stuff and sometimes conformal coating. No shorts there. So, in terms of the DC part, there's no short, which probably rules out the cap and the bridge. We check the capacitor next, which is down here. If there was a problem with the bridge, you'd get a short reading there. So, that seems alright. You know what? I'm just going to call this one a dead fuse. Actually, I mean, it could be something to do with the SCR. If there is one, that might be it down there. Actually, that looks a bit like the Zydeck, the position where it was on the Zydeck. Let's just measure that, because sometimes that will blow the fuse. Yeah, there's a low resistance there. Let's just put it on ohms, but there may be a diode across that or something, or a winding rather. 60 ohms. 60 ohms. 220 ohms, 275 ohms-ish. Yeah, I'm just going to call this one now and say I reckon it's just the fuse. It looks super tiny in there though, there's not even a bit of dust. I think this has literally no use. So I'm just going to get it back together, I think. I will inspect for dry joints here first, but then get it back together, get a fuse in, and we'll test it. But I think this one's going to be a nothing needed repair, actually. Not even repair. How to replace a fuse. Right, the board is loosely positioned here. It's not held in with any screws at all. In fact, let's just remedy that. Let's just fit one screw. I think we'll fit the one with the green stuff that was in this corner down here by the main switch, because this side of the board, it can raise up a little bit, and I'll show you in a sec. You can see there's heat shrink on the main switch there. Some of that green stuff just chips off. But can you see the diodes? I think that's the bridge. Yeah, the bridge is just down here, so I'd hate for the board there to come up. Anywhere else there, not fussed about. And let's just carefully get a 1 amp. It's marked F1 amp on the board there, and that's the fuse that was in there. Let's just get the fuse in. That's it. Now, what I'm going to do here is just position it like that. I'll leave you looking at that. Just make sure it's in the off position. Plug it in and let you see if the fuse blows. Are you ready? I'm going to look the other way here. Hang on, I don't switch mode power supplies. This is the thing. If something blows up, they can go with a blooming force. You know, parts can shatter off and fly at you, faces of transistors, etc. Yeah, so I was looking the other way. I don't know whether that flashed or not. I think that's working actually. I'm not sure I can, but I think I can hear a high frequency noise. Anyway, right, that's switched off. Let me just unplug it. I'm just going to check that fuse. You'll know whether it blew or not. So continuity test again, unplugged, important. Yeah, fuse is alright. So unless something blew open circuit, that is a possibility. There's a choke here, isn't there? Say something went wrong with that and that caused the fuse to blow, but this was open and open circuit. Yeah, that would cause that sort of situation. But anyway, I am calling it fixed. So let me just go and get that board again. Let's move these screws and things out of the way. So let's now plug it in. Now it might blow under load. Let's just see what happens now. Nope, it didn't blow under load. So we've got yeah, volts DC. Let's measure from ground to 5 volts. Look at that, 5.2324 volts. That's good. And on the op amp, I'm not sure you can see their middle pin. That's going to be plus 12. 11.9. That's really good. That's better than the Commodore one. Usually they're about 11.4 on a Commodore. Any of the Commodore ones generally, from my experience. And then the middle pin on the other side, minus 12. Well, it's a bit low, that. Minus 10.65, but that's probably normal. I think I've seen a Zydeck one that was just like that. So yeah, I might investigate the minus 12 volt rail and maybe swap the cap out on that side. But you know what? I don't think there's anything wrong with that power supply. One thing I did notice is obviously I could smell heat, but it's working fine. Can you see this wire resistor? It's right on the heatsink here for this transistor. So I'm just going to just move this away like that. Yeah, so that's probably what was heating up. I did just check on AC. That's another thing to do. Put your meter on volts AC and measure each of the rails, see if you've got any AC ripple. And there's nothing. There's nothing, and the caps look good on this. Don't even need to clean this up. It's got lots of flux of stuff on it, but you know what? I'm just literally going to reassemble this one and test and move on to the next power supply, I think. So this will make the 4th within this video, actually. So I was using a bit of IPA here. Yeah, that's like glue. And the marks are coming off that. There's like a yellowy gluey mark there. Look, it's gone. More or less. It's very clean, this one, though. So other than that white on the label, it didn't really need much clean up at all. Look at the side of that there. It's like there's barely a mark on it. It's like good as new. That's had very little use, that power supply. Yeah, there's literally no dirt coming off it. You can tell much use the power supply's had just based on its switch. This literally, it just looks new. I reckon someone's used this for like, I don't know, a year or two, and then it died and they've put it in storage or something. I think the hardest thing to clean up on this is going to be the cable, but I'll just go and get another magic eraser and use a bit of IPA. Anyway, I'm going to go test that, leave that on for a bit, I think. Yeah, and that one's powering the Amiga, no problems. So that one I'll just mark up as tested 2022, and obviously I'll test it for a number of hours here. So the next one here, it says faulty, makes, that says noise I think, makes a low noise, then whistles off at turn off. Yeah, it's another light one, it's it's 3 amp though, 5 volts 3 amp, 12 volts 500 milliamps, that's a bit lower, minus 12 at 100 milliamps, so yeah, it's not a bad one, but the 4.5 amp ones are better. That says they're A600, so yeah, this is one of the ones that would have shipped with an A600. Anyway, I'm not even going to switch it on, I don't think. Let's just get the screws out and take it apart. So while some of these power supplies are rated less than others, they're still good for 500 or a 600, even with some upgrades and things. But if you've got 1200 and you're running an 060 in there, you want the 4.5 amp one, without a doubt. But I would certainly use any of these to power a 500 or a 600. Right, that's the screws out. Let's just turn that upside down. 1, 2, 3. One's captive, 4. Let's just pull the lid off. So, pretty dusty in there, look at that. Nothing is screaming, look at me, I'm faulty. So I think the first thing I'll do is perhaps get the hoover onto this and some cotton buds and then have a bit of an inspection. Right, that's most of the dust bunnies and stuff out of there. We'll just have another quick go with the cotton bud here. There are a few things that are bent over in weird ways, like this resistor here. I would straighten anything like that out. This one here is glued to that transformer there. Yeah, you can see, look, it didn't get all the dust and fluff off this. What you can do is use a paintbrush. Sometimes I've done that when vacuuming. Anyway, I'm not really seeing anything that screams balked. So we'll test the fuse anyway, as a matter of process. Yeah, so the fuse is alright. Well, if the fuse had blown, then obviously we could have a short. The fact the fuse is alright shows there's going to be no shorts on the primary side here. So you know what, I think I'm just going to plug this in and see what happens. It may just work, I don't know. It could be over current protection or something like that. Or maybe one of the caps or diodes on the secondary side dragging a rail down, maybe. Could be something like that. There's something here, what's that? Yeah, I wonder if that's an SCR, I wonder if maybe that's balked. That's possible. It's covered in glue. Let's plug it in, make sure it's switched off first. It's off. So hopefully if it blows you'll see it. I'm just going to protect my eyes. Yep, don't think it blew. Actually no hearing. I'm actually hearing no sound from that. So, yeah, because we've got the wires easily exposed here, I'm just going to measure the voltages this way, and then we'll connect it up to that faulty board. So, switch it on. I've been careful to stay away from the heatsink there, could be live, probably is. So we're going to go down to common and 5 volts, hang on, and get onto it. Yeah, the problem is here, the wires are pretty well you know, covered at the point where you might want to measure. Not doing anything. So yes, floor cam. You don't want boards on the carpet like that. There's nothing on here that I really care about. Maybe the RAM, so I shouldn't leave it on the carpet here. But anyway, you can see the meter. Switch it on, and let's just measure the 5 volt rail here on this 7/4 series. 0 actually, so it's not doing anything, that power supply, is it? Nada. And we can check the plus and minus. Yeah, nothing. So yeah, it's making no noise, and that's what I said. I couldn't hear a sound from it. So I'm thinking we should check the choke to make sure that's not gone open circuit. You know, check the path from the bridge rectifier through. Let's switch it off. Through to the switching transistor. But the fact I hear no sound from it at all makes me think startup. So, you know, there's going to be a little resistor or something somewhere, a startup resistor, and maybe a capacitor, I don't know, somewhere. Mind you, I'm not seeing any electrolytics on the side other than the main one there. So, I don't know. Anyway, I think maybe a resistor's gone open circuit on this. You know, the one that goes between, say, the transistor, where has it gone? Here, and the transformer here to switch. It's common for that to fail on lots of these Amiga Power Supplies. Not necessarily these 600 ones. Anyway, I'm going to measure around. I'll report back in a minute. So I'm just going to clean up with cotton buds and IPA now. It is quite surprising how many different power supplies there were for the Amiga. And obviously, you know, this one is one of the ones for the 600. I wouldn't be surprised if there are 2 or 3 different ones for the 600. In fact, I know there are. There's the like epoxy block one, isn't there? That's just like a solid block of, well, epoxy. Those, I've got 1 or 2 of those here. They're not really serviceable. I've got an isolation line there, haven't you? You can see it. It's like this red line that goes all the way through the PCB, just showing you separation of the primary and secondary. Incidentally, something else you can use to clean PCBs here. Obviously you can get a specialist PCB cleaner. I've got a number of tins of that, but also acetone. Just test it on an inconspicuous area first, but there were a few channels I watched that use acetone all the time for cleaning PCBs rather than IPA. And you could argue in some places it does a better job. Now it can leave a residue if you don't clean it away, but you've got a really stubborn board like this here, acetone may bring that up a lot cleaner, you know, and then perhaps give it a rinse with IPA afterwards, because you can see wherever I do this, it comes back again. It's like a horrible smeary mess that follows the cotton bud. Yeah, look, it's still a bit streaky, but it hasn't come back like it did over here. I hope you can see that. So yeah, acetone is useful for things like that. Alright, I measured around here. We've got like 470 ohms there, 2.2 ohms there, it measures 3 actually. 270k down there, that's the one that feeds the pulse into there. 150 ohms. So the resistors around there, the big ones, certainly seem alright. There's some smaller ones down here to check, but continuity test for, let's just measure the secondary side. Because if you've got short on the secondary side, it will just shut the primary side down pretty much. You know, safety feature again. So the ground is the black wire, so from black to red. We had a beep there, but then it stopped and it's going up, up, up. So no short on the 5-volt rail. The minus 12 is the white, so between ground and white. Oh, look at that, 0, 0, 0. Complete short. So the minus 12-volt rail has shorted. Where's the plus 12? I can't see it. Yeah, plus 12 is the brown, isn't it? So let's do the plus 12. Hang on. Yeah, so the positive 12, that's fine. Reading going up, up, up. Let's check the minus 12 again. Minus 12 short. So yeah, there's a problem with the minus 12-volt rail. Now I think that's a double diode. I think that's going to be on the 5-volt. Could be wrong. We could check that. But let's just do that now. Make sure we don't have a short. No, we don't. So it's not that double diode is not the issue. There are a couple of diodes here. We could have, because it's such a low current, you see, like 0.1 amps, isn't it, or something. It says there actually, minus 12, 0.1 amp. It could just be like a Zener diode or something that's regulating that with a transistor. Maybe there's stuff encapsulated in here. Look, it could be this 3-pin device here. I think we measured that before though, didn't we? And I don't think there was a dead short there. No, there's no shorts there. Yeah, that's not a dead short. It's like 60 ohms. I think that's an SCR actually. I could be wrong. There's a wee little transistor here. It's not that. It could be the capacitor on the minus rail here that's shorted. Let's just check these two diodes as well actually. It's on diode test / continuity. Ah, that's shorted. It could be that diode there. That could be our problem. Test this one. That beefy one's going to be on the 5-volt probably. Yeah, that one's alright. So right now it's kind of looking like that diode maybe shutting the whole thing down. Let's just flip it over. There's a cap, isn't there, right next to that? Is it this one here? Let's just check that cap, but then again that cap may measure as a short. Yeah, it's doing at the moment. Now bear in mind this transformer here, we might actually be measuring the windings, but you wouldn't expect there to be a short between the ground and the minus 12, so I think that diode. Let me heat the soldering iron up and let me switch the soldering iron on. Let's get that diode out. D6, the band is towards the bottom of the board here near the opto. At least we've got a slightly more interesting repair out of this particular one. Can we fix it? I don't know. I'm always pretty pessimistic when it comes to power supplies, because you can find something simple like this, swap it out, find it doesn't work, and you're like, that's strange, why doesn't it do anything? And it could be something as simple as a short here caused the windings to short, or something like that. Do you see what I mean? Or a short in the windings caused this to short. Yeah, stranger things have happened. Let's just see if we can lift that out. Yeah, so cathode towards the bottom. It could be a Zener, and that could be the next problem here. Have I got a replacement for this? Can we read the markings on it? It's a 3UF4003 by the looks of things. That means nothing to me at this point. So anyway, let's just put that on the mat. Let's just measure actually. Please be a short. It isn't. So let's just see if we still got a short on a minus 12. We've still got a short on a minus 12. So that's interesting, isn't it? I wonder if it's got a little inductor across it. It could be one of these where there's nothing wrong with the -12 rail. Trying to follow the tracer, so one comes down here too. Yeah, a little inductor. Well, that's going to be a short, isn't it? But that rail there is obviously a winding on the transformer. But that one isn't. I don't know, I'm really confused here now. The -12 is coming through there. Because it's like the minus comes out here, goes through this diode, through a little inductor. There are 2 points there. What are those? There's a cap there and a resistor there. Let's just check those. Hang on. Oh god, I can't even see where they go now. Yeah, there's a cap here. Let's check that. Yeah, that's short. Yeah, so this is the thing. We'll have to take that cap off next, I think. I don't think it's going to be that. Just like well, we know it's not that diode. Anyway, let's take that off anyway. We can always reinstate these things once we make some progress, if we make progress. It could be one of those that if we took the transformer off, we may find there's a short between the tap that's used for the -12 and ground. Right, that's the solid points for that free. Let's just try and wiggle that off. It's glued on though. Oh, stuck to that blooming thing next to it. Yeah, it's glued, look, onto this inductor here. I think what we'll do here is just do the old Loadsa recommended thing. It's something I'd never really thought of, is got on board with some IPA and just squeeze around that. Try and prise them apart, the IPA. There we go, separates them up. So cheers for that Loadsa. So the negative, yeah, it's marked. And there's a little band that shows negative on the board. That cap may smell a bit suspect. Yeah, it's not the cap. So we're still going to have a short here, aren't we? Yep, 000. I hope it's not one of these where it's the wire. What I should do really is desolder the negative here, because you know what, it could be the wire. Sometimes they get a bit mangled, the wires on these, or pulled and stuff, but then again, it's pretty thick sleeving, so I think not. So we've got a resistor there. Let's just test that resistor, because that's on one side of that cap, I think. Yeah, strangely that resistor's kind of measuring open circuit. No, it's not. 1 ohm. Yeah, so that's 1 ohm, which is strange because it's green, blue, brown, which is like, I don't know, 560 ohms or something. So why have we got 1 ohm there? It's here, isn't it? It's these points here. Got 1 ohm. Let's just try measuring between there again, just in case it's not short. It's 1 ohm. It is 1 ohm. So maybe I'm chasing a nothing here. But then again, how have we got 1 ohm? Because that isn't 1 ohm. It's got to be one of these. I was going to say one of these inductors, but I mean, that's not even connected there now, so that winding's out of the equation. Yeah, and the diode is going to that. So it's got to be something away from the... I don't know, it depends on where... Yeah, it's got to be something else. It can't be the transformer, because that diode's not there now. So there must be something else around here that's short. Is there going to be something around here? I don't know. Let's just measure some of these piddly little things down here. Yeah, that's not short. That's not a short. That's not a short. That's not a short. Well, let's test these caps here. Let's check these caps. That's not a short. Got a cap here. That's not a short. Got a cap here somewhere. That's not a short. Of course, this is the purple one right next to the diode there, isn't there? And that is a short. Did I remove the wrong cap before? I know there were two across here. There was one there, wasn't there? There was one here. So let's remove that cap. Please let it be that cap. If it's not a cap, I'm going to get really confused. That's it. That's coming out. Yeah, it smells a bit fishy again. That is another 220 microfarad, 25 volts. Let's see how far short's gone. I bet it hasn't. It's going to be a winding thing, isn't it? Winding me up. Oh, it has gone. Short's gone. Short's gone. Yeah. Short capacitor. There we go. So, yeah, it took me a few components to trace that then, but yeah, so it was this one up here, the one next to the diode, nearest the diode, I think. Yeah, because then I made a mistake of removing the one down here, which was also across the thing, measuring the same short. So yeah, we'll replace that. Yeah, we'll replace both those bleeding caps while we're here, both on the same rail. Why not? The diode, I think, I don't know if I tested that. I know there was no short. Did I test it? Yeah, 459. Yeah, that diode's got normal forward switching in one direction. So yeah, there we go. Hopefully in a few minutes we'll have this up and running. So I've got a couple of Panasonic FRs here, super low ESR. Let's just check which way the band. Yeah, the stripe goes towards the white marking there on the board. So let's get one there. They're both slightly uprated this in terms of voltage, both 35. I think one of the ones that was on there was 25, but they've both got, as I said, low, super low ESR. That's not going in there, is it? I think what we need to do is, because the pins are so small, is just remove a little bit more solder here. Now, thinking about same brand, you know, the purple one, which I think was the purple one, wasn't it? I would swap that one on that one in that case, and check the others if they're the same manufacturer, change them all. But anyway, well, I don't think I'm going to be doing a full recap on this. I'll just check the others, I'll remove and test them. You know, this isn't like your typical failure, it is a short. They seldom short. But it does happen. Right, that's it, I think. Just want to get that leg back through. There we go. So our diode is through. Just trying to hold it from the other side. So I'm sort of holding it from the other side. I'm going to burn my fingers now, aren't I? See it coming. One. Let go. Two, just reflow that one again. That's it. So there we go. Right, so let's get it back in the case and give it a try. Place your bets. Yeah, so strangely, no voltages. Yeah, so that is blooming annoying. No voltages. We're not missing anything here anywhere, so it makes a little sense. It could be, you see, because there's no switching noise on it, it could be that this has just gone open circuit fail. I might take that transistor off and check that actually. That might be the next thing. Because we know the resistors around here are okay. The solder points are alright. And let's just check the fuse again. Just making sure it's unplugged on the set. Right, it's unplugged. Did I check the fuse in the plug before? I'm pretty sure I did. And of course you can test that from here. If you don't want to take it out, this is an additional fuse, so if you were to measure from the live pin here on connectivity to the fuse, Hang on. I'm surprised. Unless that goes... Maybe that's not the input. I think it is though, the mains comes in here. Has this fuse gone? Maybe we didn't check this fuse. I could have sworn we checked this right at the start, didn't we? I've worked... No, there's no fuse in it. Oh, there's no fuse in it. I've worked on that many of these power supplies today. It's like I'm losing the bleeding marbles here. So, anyway, if we'd have had a fuse in, we may have heard it doing a squeaking noise as it was described as, but because some moron took the fuse out of it, it's a bit crazy because you know what? Fuses, they're not that blooming expensive. At least they didn't take the plug out of the bloody thing. Right, let's just tighten these up now. I've got a fuse in. Make sure they're nice. You see, look, that earth. Oh my god, that wasn't even in. The earth wasn't even connected. That literally was not connected. I'm just going to just loosen that up, push the wire a bit further in, and then tighten it up again. Yeah, the earth was not tightened up at all. Let's hang on, look at that live. That's awful. The neutral rather. That's awful. And it's the same old problem here. I'm getting cheesed off with doing plugs. It's like the plug repair channel at the moment. Let's just undo these a bit. Yeah, because this is like right down, look. Yeah, which explains why the earth had been pulled out, but also why this, look, the neutral. Look at that, it's not even in. What has happened to this blooming connection here? That's it. I think what's happened there is someone's tried to push it in incorrectly. In other words, what they've done, hang on. They haven't had this terminal here unscrewed all the way so that there's a nice spherical passage for the wire. And then of course when you shove the wire in, it scrunches up. Yeah, so it's not easy to do this. There we go, I can lift that out a little bit. What we need to do is just assist it in here, hang on, so that we don't fold it. There we go, like that. So you can see that's gone right in, and then tighten it. That's it. So that's nice and tight. Push that back. Try and manipulate these wires here into the cavity. That'll do. Make sure there's enough for it to grip on the cable relief here. I don't like that live sticking up like that. That live is a bit too long. I think off camera I may just adjust that later. Right now though, I just want to just make this relatively secure and plug it in again. What is annoying, if I check that fuse at the start there, you know, it's the Occam's razor stuff, isn't it? But that isn't the fault. The fault was the minus 12 volt rail. We would have heard the squelching or whatever it is. Is it, you know, you can hear the switching and stuff as it goes off and on the cast. If that isn't, that's good. So I'll just move the live down a little bit. See if we can get the cover back on, and give it another try. Anyway, it's a good job I went in there, because if it had a 13 amp fuse I wouldn't have remembered to check that one. I thought I'd already done it. I'm going to plug it in, get rid of a bang. No bang. Switch it on. No bang. Right, I'm going to try and measure from the top side here now, I think. Switch it on. So we're on volts DC, it's on. Let me measure from the 5 volts down there to common. And we have nothing still. Are you kidding me? Oh no, we do, look. 3 volts, see that? Now, the 3 volts is probably because there's no load. Switch it off. This must be one of these where, if it's not plugged in, it don't measure the voltage. So, plug it into the dummy board down there. Switch it back on carefully. And try and measure these again. I really need a power lead or something on that board so I can see that it's powered. Look at that, 5.2 volts. Let's check the minus 12, so this was the one that was shorted, minus 11.74, and the brown, which is the positive 12 volts, if we can get onto it, 12 volts, there we go, that's another one fixed. So, as I say, if you were, you know, fully preventative maintenance in this power supply, you want to replace the other caps. I will just, you know, clean up the board further, take these caps out of here. It's still on, by the way, switched it off. Take those caps out round there, check them and replace as according, but I bet you could run that for another 10 years and probably never have another cap short on it. It's just one of those things where one cap, for whatever reason, a defect, and manufacturers just decided to, you know, give up the ghost. So I'm going to swap the remaining caps here. I've got a bunch of them here. That one's a bit big, but that's the one to go there, 2200. That is an SCR. It's marked down there, SCR. That was a good guess, wasn't it? Yeah, whenever you see a 3-pin device, this end on the secondary side like that, that's not on a heatsink, you tend to find it's an SCR on these. I mean, don't just assume that, but I've seen it enough times now to make me assume it. Of course, you know, you get things like that for regulators. It could be a 7805 or a 7812. This is a thing, or even one of those double diode things. Anyway, yeah, I'm going to just whiz through these. We'll test these on the ESR meter as well. We'll start with this one down here. The only one I've not got is a 680 microfarad, so I've got a 1000, I think. I'm going to substitute that for there. Let's just uprate it. It's no problem, as I said in a previous video, uprating on the secondary side there. So with those bits of glue there, I'm just going to heat those just to get them secure that cap, and I may just melt this bit here as well just to get that to join there. We've got a bit of glue here that came from maybe in between these two, so I'll just do that. I'll just melt those and I'll show you the end result. Yeah, that last little bit there that was spare, and wedged it there in between the two things here, the inductor and the cap. Like I say, you can control where it goes by tilting and blowing it. So yeah, I just wrote in red ink here, caps, you can't read it very well, 2022 with a red blob there and everything's marked up. Yeah, so the only one we haven't done is that one. So the heatsink clips off from the other side. I've got most of the old thermal compound off there, and just get some fresh on there. It was all dried and crusty, just like that last one where I did this. You know, sometimes they're riveted on. When they're not riveted on, I will take opportunity, as I'm doing here, to put some new thermal compound on. Insulation tab is obviously critical with something like this, because you don't want it to short. Yeah, you could think there's a screw point there isn't. It literally just merges with the heatsink like that, and then this just squishes onto that, and then the clip, if I can get the clip up. Hang on, let's just wipe all that gunk off there. It'll look a bit cleaner in a minute when I've got some IP on the cotton bud. Yeah, it goes through the thing there like that. You're gonna press it. That's it. So that is in place. Right, there's still a few bits of dust and fluff around the place. Yeah, I could get some heatsink compound there, but you know what? I'm not too worried about that. It's more that I am worried about. That label survived the wash, but it's still hanging upwards, you know, on one side. So I'll get some glue. I'm going to stick that back in. So we're switched on. Let's measure from crusty carpet board. Yeah, there we go. 5.18 volts, and the plus 12, 11.6, minus 12, minus 11.6. Yeah, that's spot on. So we can test that on the Amiga. But before I do that, I'll just clean up the cable and stuff. You've seen me do that so many times now. I will show getting some plastic polish on these black marks here, though they should come off. There's just one or two scratches. So a bit of Maguire's plastics here. It's interesting this one's not yellowed. It looks almost good as new if it wasn't for these little marks. Let's see if that black mark there will clean up. Yeah, not much. Is that coming off? Yeah, it's coming off a bit, look. You can see, because it's ingrained like that way, this is where you've got to rub in that orientation. Again, losing track whether I've cleaned this one or not. I've been working on that many of these. You know, you're just seeing this one video here, and I might be working in just this one power supply, or maybe two or three. But yeah, I've been working on them for a number of days now, well, a few days. And this must be like number 6, I think I've done. So yeah, it's easy to forget what you've done, what you haven't done. Whilst I've not replaced the caps in every single one, what I have done is all of this sort of stuff, the standard stuff, cleaning the case, cleaning the cable, checking the capacitors, and cleaning these connectors this way, getting rid of all that black, you know, contamination that's on there from years of, you know, usage, arcing, weather, etc. And you can see what I mean. Those are the ones that I've done in the last 24 hours. And I'm not sure you can see here, but look how clean this cable is. It's like new on both sides. The whole power supply is like new. There's literally no marks. The black marks that were up here have come off. So yeah, that's another one that is in excellent condition now. So again, I'll just leave it on test for a number of hours, a few different power cycles, you know, for 3 or 4 days. But I'll leave it on for 2 or 3 hours at a time at least. So just going through those caps. Remember, one of these is a dead short. I'm not sure which one it is. 0.12. So that's like 1,000, and it's showing okay, isn't it? It's ESR. And this one's a 220, is it? I think. Yeah, 0.9. In circuit leaky. So that's the one with the short, I think. Yeah, that's the one with the short, showing 0.01, but that is shorted. Let's test this one. Unless 2 of them were shorted. You could argue this shows it was a good idea to replace them if that's not the one that was shorted. See what that comes out. Yeah, that one's alright. 0.38, 250, it's actually 220. This one's another 220, I think. In circuit leaky, so hang on, unless those were shorting, and maybe I just shorted the probes there. It's just, yeah, that's alright. 0.35, 225, 252, so it's a bit higher, but yeah, it's just going to be that one, isn't it? I think the ESR of these are going to be probably okay. So this one's I think 2,200, 0.01, or 0.1, 2,500. So this is the thing, and the ESR report seems to be good. Again, low ESR. Yeah, so microphone rating a bit low there, 630. So yeah, anyway. Didn't all need swapping out, but we did it anyway. It's had a lot of use, and the thing is, it was covered in fluff and dust, so that was a clue to me. When you got that much dust and fluff in there, it must have been used in a bedroom somewhere for, you know, a lot of hours. That previous one we looked at was like I don't know what it was, Amitech or Zydek or something. That one, it looked brand new. It looked like it had literally never been used. So there will be some more power supply repairs coming up, hopefully with some different faults. If you'd like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.